This is the Business Blackbook, where billion-dollar empires are built and collapse. You ask a chatbot 10 questions, and somewhere on this planet, a bottle of water disappears. Not metaphorically, not approximately, literally. Every single time you type a prompt into an AI system, servers are working, cooling systems are running, and water is evaporating. And with hundreds of millions of people using these tools every single day, the scale of what is being consumed quietly in the background is something most people have never stopped to think about. Today we are going to decode exactly that. How the artificial intelligence boom, which everyone is celebrating as the future, is quietly placing enormous pressure on one of the most essential resources on this planet. Water. Not oil. Not electricity. Water. And by the end of this video, you will understand the full system behind it, why it is happening, why it will get worse before it gets better, and what it actually means for the world you live in. Let us start from the very beginning. When you think about the internet or artificial intelligence, the natural image that comes to mind is something invisible. Wireless signals, digital clouds, data floating through the air. But that image is completely wrong. Every message you send, every search you make, every question you ask an AI, every email that lands in your inbox, all of it runs through physical machines, real buildings, real hardware, real infrastructure. And that infrastructure generates enormous amounts of heat. These buildings are called data centers. Think of them as the physical brain of the internet. Rows upon rows of servers, the size of warehouses, working continuously, storing information, processing commands, transferring data, 24 hours a day, 7 days a week, 365 days a year, without pause. And all that computing power converts almost entirely into heat. Now here is where water enters the picture. If you allow servers to overheat, they fail. And when servers fail at this scale, entire systems go down. So these companies must cool their machines constantly. And the most common, most effective, most widely used method of doing that is water. There are two primary ways companies manage this cooling. The first is cooling towers. Think of them as giant industrial air conditioners. They take the heat generated inside the building and expel it into the atmosphere through a process called evaporation. Water is used, heated, turned into vapor, and released. That water is gone. It does not return to the local system. It evaporates. The second method is called outside air cooling, sometimes called free cooling. This system pulls in cooler outside air and uses it to bring temperatures down inside the building. It sounds efficient, and it can be. But here's the problem. When outside temperatures rise, during summer months, during heat waves, during droughts, this method stops working on its own. And water evaporation has to be brought back in, which means the hottest months of the year, when water is already most scarce, are exactly when these data centers consume the most of it. Now let us talk about the numbers, because this is where the picture becomes truly serious. Microsoft disclosed in its latest environmental sustainability report that its global water consumption rose by more than 1/3 between 2021 and 2022. In one single year, it climbed to nearly 1.7 billion gallons. To give you a sense of scale, that is the equivalent of more than 2,500 Olympic-sized swimming pools, built in 1 year by one company. Google reported that its total water consumption across data centers and offices came in at 5.6 billion gallons in 2022. That was a 21% increase from the year before. 5.6 billion gallons, enough to fill nearly 8,500 Olympic pools. And here's the part that should make you pause. These numbers were reported before Microsoft launched Bing Chat and before Google launched Bard, before either company had rolled out their AI products at scale. The water footprint we are discussing right now is the footprint before the AI race fully began. Researchers at the University of California studied this closely. Their findings suggested that globally, AI demand could be responsible for up to 6.6 billion cubic meters of water withdrawal by 2027. That figure, 6.6 billion cubic meters, is roughly equivalent to the total annual water withdrawal of the entire state of Washington. Let that number settle for a moment. The computing power required for AI is estimated to double every 100 days and is expected to increase by more than 1 million times over the next 5 years. Not double, not triple, 1 million times, which means the water requirements attached to that computing power are also on a trajectory that the current infrastructure of this planet is not designed to handle. So why does this problem exist in the first place? Part of the answer is geography. The United States alone operates more than 5,300 data centers. That is 10 times more than Germany, which is the second largest operator in the world. Most of these data centers are not located in cold climates where free cooling could work year-round. They are spread across regions with warm summers, variable climates, and populations that are themselves dependent on the same water systems. If a data center were placed in a colder environment, near Iceland or northern Canada, for example, the need for water-based cooling would drop significantly. But that is not how the current infrastructure is built. And moving, rebuilding, or restructuring it is not something that happens in a year or two. The second part of the answer is incentive structure. For a long time, these companies were not required to disclose their water usage in most parts of the world. When there is no disclosure requirement, there is limited public pressure. And when there is limited public pressure, there is limited urgency to change. That is beginning to shift. The European Union has introduced increased requirements for companies to disclose their water usage. Researchers and ethicists are calling for more regulatory intervention. But the gap between where the regulation is today and the pace at which AI is scaling is still very wide. The third reason is the AI race itself. OpenAI, Google, Microsoft, Amazon, Meta, every major technology company is in a full sprint to build more powerful models, faster, with greater capability. That competition creates a pressure to scale infrastructure rapidly, not thoughtfully, rapidly. And rapid scaling means more servers, more heat, more cooling, more water. Now let us clear up a few things that are commonly misunderstood about this issue. The first misconception is that data centers only affect the electricity grid. Most public conversation around the environmental cost of AI focuses on energy, carbon emissions, electricity usage, and those are real problems. But water is a separate and in many ways more local problem. Electricity can be sourced from renewables. Carbon offsets can be purchased, but water is location-specific. When a data center in a drought-affected region pulls water from a local aquifer, that water is not being replaced by a wind farm somewhere else. It is simply gone from that community. The second misconception is that this only affects wealthy countries. In July of 2023, protesters took to the streets of the capital city of Uruguay. They were demonstrating against Google's plan to build a data center in their country. Uruguay at that time was experiencing its worst drought in 74 years. The local population was struggling with water access, and the largest technology company in the world was preparing to consume vast quantities of that same water. Google stated the project was still at an exploratory phase and emphasized sustainability as part of its mission. But the conflict itself was real, and it was a preview of what researchers believe will become a much more common kind of tension globally. The third misconception is that this is a distant future problem. Some people hear these statistics and think, well, that is 2027. That is years away. But the data centers being built today, the infrastructure being laid right now, will be operational for decades. The decisions being made in boardrooms this year are locking in water consumption patterns for the next 20 or 30 years. The future is being built right now. So what does all of this mean for real people? For someone living in a water-stressed region, It means your local government may be approving permits for infrastructure that competes directly with your household and agricultural needs for the same resource. That is not theoretical. It happened in Uruguay. It is happening in parts of the American Southwest. It will happen in more places. For business owners and investors, it means water risk is now a technology sector risk, not just a farming sector risk or a manufacturing sector risk. Any company deeply integrated with AI infrastructure needs to start thinking about where its data is processed and what the long-term water availability looks like in those regions. For students and working professionals, it means the tools you are using every day, the AI assistants, the search engines, the recommendation systems, all carry a physical cost that is not reflected in the free tier pricing. Someone, somewhere, is paying with water. For policymakers, the challenge is governance. What the research community is increasingly calling for is an international framework that can monitor and regulate the water footprint of AI at a global level. Because water does not follow national borders, and neither does the cloud. What a financially and systemically aware person understands from all of this is the following. Technology is never truly weightless. Every digital convenience has a physical cost. The AI revolution is real, it is powerful, and it is bringing genuine capabilities to the world. But it is also running on infrastructure that consumes one of the planet's most finite and unevenly distributed resources. The companies involved have made commitments. Both Microsoft and Google have pledged to become water positive by the end of this decade, meaning they aim to replenish more water than they use. Those are meaningful commitments. But the gap between current consumption trajectories and those goals is enormous. And the commitments were made before the full-scale AI build-out was underway. The question is not whether AI will continue to grow. It will. The question is whether the growth will be governed, measured, and made accountable to the communities whose water it depends on. Understanding this system does not require you to stop using technology. It requires you to understand the real cost of what you are using, and to ask better questions of the companies and governments that are making decisions that will shape water availability for billions of people. That is what an informed person does. They see the full system, not just the product. And with that, the Black Book closes. Subscribe, and we will open the next page soon.